Welcome to Mythos AI, your source for Cliff's Notes on complex subjects. Join Anna and Phil for yet another engaging conversation.
All right, so get this. You know how everyone's freaking out about AI taking over the world?
Mm-hmm.
Well, today, we're diving into something even wilder.
Mm-hmm.
What if AI just runs out of juice? You sent us some seriously interesting research on AI's energy consumption.
Yeah.
And let me tell you, it's making me rethink those late-night chat GPT chats.
It's interesting, isn't it, that we're really seeing the physical limitations of energy production colliding head-on with this seemingly limitless world of AI.
Right.
And we're not just talking about, ones and zeros anymore. We're talking megawatts, terawatts,
Yeah.
the kind of power that keeps entire cities running.
Yeah, I mean, that's what's so mind-blowing to me, right? Like, we're so used to thinking of the digital world as the separate thing.
Right.
But training these AI models, it's not just some abstract process that's happening, in the cloud somewhere. It requires a staggering amount of energy.
Absolutely, yeah.
Yeah.
Take GPT-3, for example. Training that model consumed a mind-boggling 12 gigawatt hours of electricity.
Right.
To put that into perspective, that's enough to power over 1,000 homes for an entire year. And that's before it even generates a single line of code or writes a poem or anything.
Okay, hold up.
Yeah.
So just to get these AI models ready to go, we're talking about the same amount of energy as a small town?
A lot of energy.
That's insane.
Yeah.
But once they're trained, though, it's smooth sailing.
Not quite. Every time you interact with an AI, whether it's asking, ChatGPT a question or using an AI image generator,
Right.
that's called inference.
Okay.
And every single instance of inference consumes energy, albeit on a smaller scale.
Right, it's like the phantom load of our digital age.
Exactly.
These tiny little sips of energy might seem insignificant on their own, but
But you multiply that by millions, even billions of users worldwide,
yeah.
and suddenly we're talking about powering entire countries just to fuel our AI habit. It's like we've unleashed this energy monster, and now we're scrambling to figure out how to feed it.
So what's the plan? How do we keep up with this insatiable demand?
Well, there are several strategies being explored, and it's going to require a multifaceted approach.
Okay.
One avenue is a full-blown hardware revolution.
Okay, let's unpack that. What kind of hardware are we talking about?
Companies like NVIDIA and Google, who are at the forefront of AI development, they are laser focused on developing more energy efficient chips specifically designed for AI workloads.
Mm-hmm.
It's like comparing those clunky energy guzzling computers from the 80s to the sleek energy sipping laptops we have today.
Oh, yeah. I can barely picture myself using one of those things now.
Right.
So are these new chips just about making AI faster, or is it about doing more with less energy?
It's about both.
Okay.
But efficiency is key. We're talking about a paradigm shift in chip design, a quantum leap forward in energy efficiency that could significantly reduce the energy footprint of AI.
Okay, that's encouraging.
Yeah.
But even with these super efficient chips, won't we still need massive data centers to run everything?
We will.
And aren't those notorious energy hogs?
You're right. Data centers are energy intensive,
Yeah.
but there are creative solutions emerging there as well.
Okay.
Imagine strategically locating data centers in naturally cold climates like Iceland or Alaska.
Now that's clever.
Yeah.
So instead of blasting the AC to keep the servers cool, they're letting Mother Nature lend a hand.
Precisely. This natural cooling significantly reduces the energy needed to keep those servers humming along.
Mm-hmm.
And some companies are even experimenting with underwater data centers, which offer even more efficient cooling.
Underwater data centers. That sounds straight out of a science fiction novel.
It does, doesn't it?
But as cool as these innovations are, literally in some cases, I can't help but wonder, are we just slapping Band-Aids on a much larger problem?
It's true that these are important steps, but they might not be enough on their own.
Right.
That's why there's a massive push for renewable energy sources like solar and wind to power these AI behemoths.
Yeah, it seems like every tech giant is building solar farms and wind turbines these days. But can those really keep pace with AI's, growing hunger for power?
It's a race against time,
Mm-hmm.
and scaling up renewable energy production to meet this demand is a monumental challenge. But it's not just about the amount of renewable energy we generate. It's also about how we distribute it.
Right, because having all that clean energy doesn't do much good if it can't reach those power-hungry AI systems.
Exactly.
So are we talking about a complete overhaul of the entire power grid?
We're talking about something called grid modernization.
Okay.
Imagine a smarter, more robust grid that can handle the fluctuations of renewable energy sources and efficiently deliver power where it's needed most. Think of it as upgrading from dial-up to high-speed internet for our entire energy infrastructure.
Okay, that's a serious upgrade. But while renewable energy sounds promising,
Yeah,
I have a feeling there are more controversial options on the table.
you're reading my mind. And this is where things get really interesting because we have to start talking about nuclear power.
Nuclear. Okay, that took a turn. It's not exactly the first thing that comes to mind when I think eco-friendly solutions. So why nuclear and why now?
Yeah, I hear you. It's a loaded topic for sure. But with AI's energy demands growing exponentially, we have to explore all options.
Right.
And right now, nuclear is back in the spotlight for a couple of reasons.
Okay.
First, it's about scale. Nuclear power plants can generate enormous amounts of energy from a relatively small footprint compared to, say, sprawling solar farms.
So in terms of sheer output, nuclear packs a punch.
It does.
But what about the whole clean energy aspect? I thought nuclear power meant radioactive waste and potential meltdowns.
You're right. Traditional nuclear fission, which is what powers today's plants, does come with those risks.
Mm-hmm.
But it's also one of the most reliable sources of low-carbon electricity we have. And there have been significant advancements in reactor safety and waste management.
Okay, so maybe fission isn't as scary as we sometimes imagine. But didn't you say there were a couple of reasons why nuclear is back in the conversation? What's the other one?
Fusion. Remember that holy grail of clean energy I mentioned earlier?
Yeah.
It's the same process that powers the sun, fusing atoms together to release incredible amounts of energy with virtually no greenhouse gas emissions and minimal waste.
Fusion. It sounds like something out of Star Trek. Isn't that still the stuff of science fiction?
It's been the dream for decades, but there have been some major breakthroughs in recent years. We're still in the experimental phases, but the science is solid.
And I'm guessing this is where the tech giants come in. They're not building experimental fusion reactors, are they?
Well, not exactly reactors just yet, but companies like Google and Microsoft are investing heavily in fusion research.
Mm-hmm.
They see the potential of fusion to solve our energy woes, not just for AI, but for the entire planet.
That's a pretty clear signal that fusion might be more than just a pipe dream. But even with these advancements, aren't we still talking decades before fusion power becomes a reality?
Yeah, it's not a quick fix.
What's the plan in the meantime? Do
Yeah.
we just hit the brakes on AI development while we wait for these futuristic solutions to pan out?
It's not about hitting the brakes. It's about finding a sustainable pace. And that brings us to another critical aspect of this conversation, algorithmic efficiency.
Okay, so this is where we get into the weeds a bit. You mentioned this earlier, but I'll admit it's a bit of a head scratcher for me.
Think of it like this. Imagine training an AI to recognize different dog breeds. Traditionally, you'd need to feed it millions of images.
Right.
But what if we could achieve the same level of accuracy using a fraction of those images?
Okay.
That's essentially what algorithmic efficiency is all about. Optimizing algorithms to reduce the number of computations needed, which in turn reduces energy consumption.
So it's like teaching AI to think smarter, not harder.
Exact.
And this isn't just some theoretical concept, right? Are there real-world examples of this happening?
Absolutely. Researchers are developing new techniques to compress AI models, optimize code, and even design algorithms that are inherently more energy efficient. It's an ongoing area of research, but really results are promising.
That's encouraging. But let's shift gears for a moment and talk about a major player in the AI game, China. They've been investing heavily in AI, but can they keep up with the energy demands?
China's playing a fascinating game. They're acutely aware of the energy challenges posed by AI, and they're making strategic moves to secure their position.
Like what kind of moves are we talking about?
Well, for starters, they're going all in on renewables.
Okay.
We're talking a massive expansion of solar and wind power on a scale that dwarfs most other countries.
Wow.
They're also investing heavily in energy storage solutions like giant batteries to address the intermittency issues of renewables.
Wow. They're not messing around.
Good.
But they're not relying solely on renewables, are they?
You're right. They're hedging their bets with a combination of renewables, nuclear, and yes, even fossil fuels.
Mhm.
They're building new nuclear power plants at an astonishing rate, and they haven't shied away from utilizing coal and natural gas to fuel their economic engine, which of course includes their burgeoning AI industry.
That's a pretty diverse energy portfolio, but I have to ask, given the environmental concerns, Is it ethical for them to rely so heavily on fossil fuels, even as they ramp up their renewable energy production?
That's a complex question with no easy answers. Some argue that it's a necessary evil, a temporary bridge to a cleaner future, while others criticize it as short-sighted and environmentally damaging. It's a delicate balancing act between economic growth, energy security, and environmental sustainability.
It seems like there's no easy answer there. So where does that leave us? So we've covered a lot of ground here. Energy sipping AI chips, underwater data centers, the promise of fusion power, even the ethical dilemmas of fossil
A
fuels.
lot to think about.
It feels like we've traveled through time, exploring both futuristic solutions and the stark realities of our current energy landscape.
We have.
So where does this all leave us? Can we really power the AI revolution without frying the planet?
That is the million-dollar question, isn't it?
Huh.
And like most things in life, there's no easy answer. It's not a simple case of flipping a switch to renewable energy and calling it a day.
Right.
We're talking about a fundamental shift in how we generate, distribute, and consume energy.
It sounds like we need a complete paradigm shift, not just incremental change.
Exactly. It requires a multifaceted approach, a combination of technological innovation, policy changes, and, dare I say it, a bit of global cooperation.
Yeah.
We need those energy-efficient algorithms and hardware, but we also need to rethink our energy infrastructure. Imagine a world where smart grids seamlessly balance renewable energy sources, where energy storage solutions smooth out the peaks and valleys of solar and wind power.
It's almost like we need to reimagine our entire energy system, not just for AI, but for everything.
Precisely. And here's the interesting thing. AI itself might be a key player in this energy revolution.
Okay.
Remember those smart grids we talked about?
Yeah.
AI can be the brains behind those systems, optimizing energy distribution and consumption in ways we can't even imagine yet.
So AI, the energy hog, could become AI, the energy savior. That's a plot twist I didn't see coming.
It's true. And it goes beyond smart grids. AI can accelerate the development of new battery technologies, help us pinpoint the most efficient locations for renewable energy installations, and even play a crucial role in making fusion power a reality.
That's incredible. But even with all these advancements, aren't we still looking at a future where certain countries, like China, with its aggressive energy strategy, might have a significant advantage in the AI race?
It's a definite possibility. The countries that can secure access to abundant, affordable, and sustainable energy will undoubtedly have a leg up in the AI-powered future.
It makes you wonder, will AI exacerbate existing geopolitical tensions, or could it foster a new era of collaboration as we grapple with these global energy challenges?
That's the billion-dollar question, isn't it? And one that will likely shape the geopolitical landscape for decades to come. It's a reminder that the future of AI isn't just about algorithms and processing power. It's intertwined with the very resources that power our world.
This deep dive has been a wild ride. We've explored the energy demands of AI, uncovered potential solutions, and even stumbled into the complex world of geopolitics. It's clear that the future of AI is intricately linked to the future of energy.
Absolutely. And it highlights the fact that we're not just passive bystanders in this technological revolution.
Right.
We have choices to make as individuals, as industries, and as a global community.
Choices about the kind of future we want to create. So to our listeners, as you fire up your AI-powered devices, remember that every interaction from asking Alexa about the weather to generating stunning images with AI art tools consumes energy. It's up to all of us to demand sustainable solutions and support the innovation that will power a brighter, more sustainable future for AI and for humanity.
Well said. The future is unwritten, but the choices we make today will determine whether it's powered by innovation or unsustainable by our own creation.
That's a powerful thought to leave us with. Thanks for joining us on this electrifying journey into the world of AI and energy. Until next time, stay curious, stay informed, and let's all do our part to keep the lights on sustainably.
Thanks for listening to Mythos AI. Stay tuned for more concise insights. And remember to hit the like button and subscribe for future episodes.